Right, hi. So, just for a bit of fun, genuinely, I've decided to make a predicted question for GCSE Physics AQA Paper 1, Energy. It's the most thing I'm most asked, what do I think will come up? I have no idea what's going to come up. This is literally just for a bit of fun for me, which is sad, but also because I know you guys like to tackle questions you haven't seen before, and there's no way you've seen this because I literally just made it up myself. So, this is the question. A student is experimenting with a pop-up toy. The pop-up toy is a mass of 20 grams connected to a spring with a spring constant of 67 newtons per meter, and then G is 9.8 newtons per kilogram. Gravitational field strength. The student compresses the spring by 5 centimeters and then releases the toy. Obviously, I imagine they'd have more context than that, but this is my little drawing. It's one of those little pop-up toys. Just squish the spring down. It maybe waits there for a bit or it doesn't, and then it kind of flies off and it reaches a kind of height above the ground, right? Describe the energy transfers that take place for 3 marks. Part B, calculate the maximum possible height the toy could reach, which I think would be like a 6-marker calculation. And then part C, what assumptions did you make in your calculation for 2 marks? If you want to do it, which I recommend you have a go at doing it, then pause the video and have a go at it. And then I'm just going to unpause and then you can watch me do it. So pause it now. Okay, so I'm going to go through it now. Again, this is just for fun. Who knows what the mark scheme would be for these, but if I was writing this question, this is what I would do. So the energy transfers that takes place for 3 marks. So we're thinking about the different situations the toy is in. So it's here, then it gets compressed, and the energy store of the elastic potential energy of the toy is going to increase, and then the elastic potential energy is going to be converted first into kinetic energy as it flies up, and then that kinetic energy is going to be converted into gravitational potential energy. Now, all these things will be transferred mechanically because it's all forces acting on the spring. And obviously, I could say energy dissipated to the surroundings. So, first of all, I'm going to say work is done on the spring mechanically. Then I'm going to say this increases the spring's store of elastic potential energy, or EE. I'd probably write it out in an exam. Elastic potential energy. This EE, so when the spring is released, the elastic potential energy is converted into kinetic energy, or EK, and then as the toy moves up, the kinetic energy is converted into gravitational potential energy, right? And at the top, all the energy is gravitational potential, or EP. EP, mgh, ek half mv squared, ee half ke squared. I could also, I guess, if I wanted to, say that the student compresses chemical energy in the student's body to compress the spring. I mean, but plenty to say there for 3 marks. Calculate the maximum possible height the toy could reach. So we're trying to find the height. We've got lots of stuff in here. We've got the mass is 20 grams. Now, I know 20 grams is not the right unit for mass, so I'm going to write mass is 20 grams, which I need to convert into kilograms, which is 0.020 kilograms. Then I'm going to write the spring constant I've got, which is 67 newtons per meter. That's fine. Newtons per meter, that's what it should be in. I've got G is 9.81 newtons per kilogram. Sorry, 9.8 newtons per kilogram. At A level, it's 9.81. Then the student compresses the toy. So the extension or the compression of the spring is 5 centimeters, which is 0.05 meters, right? So 2 conversions to do, get them out of the way. And then I'm trying to find the maximum height that the thing can reach. Now, I can't use these things to find the maximum height. Figures, it's an energy question, so figures I'm going to use at the end. EP is equal to mgh from the calculation. And I've got G, which is fab. I'm trying to find H. I've got M, but I don't have the potential energy. I don't have the gravitational potential energy. And they've given me the spring constant, so it kind of, well, I've given me the spring constant. So it stands to reason that I'm going to use elastic potential energy is half Ke squared to calculate the elastic potential energy, and I'm going to assume that all gets converted into the gravitational potential energy. At the interim, I could convert that into kinetic energy, but if I just think about the start when it's stationary here, and then when it's reached its maximum height there, we'll figure out what it's going to be. So first of all, elastic potential energy is half Ke squared, so I've got my equation there. I'm going to substitute, so it's a half times 67 times 0.05 squared. And I'll do that on my calculator, and I get the elastic potential energy is 0.08375 joules. Nice and easy. Then I'm going to say, well, that energy gets converted into gravitational potential energy, the maximum height. And so 0.08375 joules is going to be, oh, I'll just leave that off because it might be confusing. It's going to be equal to my mass, which is 0.020 times 9.8 times the height. Divide, so I'm going to do that sum because I don't like getting muddled up with these things. So I'm going to do 0.020 times 9.8, and that's what I always recommend you do. If you can tidy up your equation before you substitute, do so, because it's easy to make mistakes in the stress of the exam. And if this way I've shown exactly what I've done, that's 0.196h, and then I'm going to divide both sides by 0.196. 0.196 to get a value for h. So 0.08375 divided by 0.196, and it is 0. The height is going to be 0.42729 meters, and I'm just going to put that in two significant figures. So I'm going to say 0.43 meters. You don't have to do that. It doesn't ask you to do significant figures. That number would have been fine. And actually, half a meter for those toys, that's maybe makes sense. You know, I'm just going to common sense check it. That seems like it might be all right. What assumptions did I make in my calculation? Well, potentially loads. The biggest assumption I guess I made is that the toy and the spring forms a closed system. So once it's been compressed, it's a closed system. There's no net energy transfers. Otherwise, I'm saying no energy dissipated to the surroundings, or like no energy to thermal energy of the surroundings. And I'm going to say that I've assumed that it's 100% efficient. So the conversion or the transfer of elastic potential energy to gravitational potential energy is 100% efficient. And maybe it's not, maybe it's only 70% efficient, and then I've got to find 70% of the height. And the other thing is I've kind of assumed that it's a point mass. So like, where is the mass off the ground? What's the bottom of it? I've not really worried about that. I've assumed it's the toy acts as a point mass. Very well, that might actually end up making the calculation irrelevant. I mean, I'm really keen to hear what you think of this, so please comment and let me know. And let me know if you want me to do more of this sort of thing, or if you prefer I go back to going through content. But like I say, this is not a prediction. I have no idea. It's just a bit of fun.